Welcome to ETHDam, to ETHDam, to ETHDam, to ETHDam, to ETHDam.
Okay guys, before he introduces me, I just have a request. When I say the word excellent, I need you to use your best surfer or skater voice and go, "No way!" Can you do that?
No way!
Oh yeah, perfect.
Gnarly!
That's excellent.
No way!
Really? That's the loudest you can be? They barely pick it up on the mic.
Dude.
Okay.
All right, we're back on time. Can you believe it? I can't. Next up, we have Privacy is Normal with Lauren Harkness. Thank you very much.
Thank you. Give it up for me! Yeah! Give it up for me! I'm going to channel my inner Steve Ballmer. Developers, developers, developers.
BitConnect.
Yes. Okay. ETHDam actually stole the title of my presentation. Privacy is Normal. I think I came up with that first. My name is Lauren Harkness, and I'm here with Shutter Network. And Shutter is a protocol which does commit and reveal threshold encryption. Now, I'm not going to nerd out on you and be super technical. Instead, I'm going to take you on an excellent adventure.
No way!
Yes, way! So, join me as we traveled through time and space to the year 1268. The world back then was crazy. There was conflict in the Holy Land. Rome was overrun by thieves. The Pope had just passed away, and there was a conclave to elect a new Pope. Because Rome was such a cesspool, the 20 cardinals came here to the picturesque hillside town in Viterbo, just north of Rome, and there they set out to elect a new Pope. But things did not go well. There were political rivals. There were different factions. No one could agree on a new Pope. Even worse, people were not playing fair, and the process was not credibly neutral. Some of the cardinals actually forged ballots. Others bribed the officials. There were backroom deals. The whole process ended up taking 2 years and 9 months. And the townspeople in Viterbo became so frustrated with the cardinals that they actually locked them inside the papal palace. That's where we get the name Conclave, Conclave with key, okay? They also restricted their rations to mere bread and water, and at one point, they even removed the roof overhead, exposing the cardinals to the elements in order to speed up the decision-making process. Fortunately, Pope Gregory X was actually a very good pope and introduced a number of governance reforms and tools to make the process more fair and credibly neutral. One thing was secret ballots. So the cardinals would write their name down on a piece of paper and also write the name of the person they would like to elect pope. They would fold the paper in half and they would deposit it into one of these gold and silver urns. Now, all of the ballots were collected before the urns were opened, and then there were 3 officials, and I know that they were enjoyers of governance because they're called the 3 scrutineers. Yes, they were crypto bros. The 3 scrutineers would each do their own independent count and in parallel release the results. That way, it was verified not just once, but 3 times. So, let's go back to the future. The year is 2025, and the world is a crazy place. There's conflict in the Holy Land. Rome is still a den of thieves. Sorry, Romans. And the governance process, which is used at the conclave, is still used to this day. Congratulations to Pope Leo XIV. Well done, by the way. USA. No. Why did I tell you this story about the papal conclave? It's because this is kind of a mechanical way of doing commit and reveal threshold encryption. And if I were doing a normal crypto talk, I might tell you in intricate, painful detail about how it works. I would tell you that with commit and reveal threshold encryption, that all the players encrypt information and then commit to it. Then they would wait until a specified time period or event has passed, and then a distributed group of nodes would collaborate to generate a decryption key, and then anyone could take that key, decrypt the information, and publish the results. But I'm not going to do that. If I was doing a normal crypto presentation, I might talk about the game theory behind commit and reveal threshold encryption. And I would tell you that it promotes credible neutrality by eliminating information asymmetries in simultaneous move games. But I'm not going to do that. Or I might tell you about some obscure benefit which the system yields, like preventing front-running, real-time censorship, and manipulation. Or I might tell you that it prevents privileged actors and trusted centralized third parties. Am I going to do that? No. Instead, I know that you have problems, and so I'm going to help you solve them. I'm going to talk about everyday use cases of commit and reveal threshold encryption. Things which are important to you. Things like managing a treasury, winning friends and influencing people, and most importantly, surviving. So let's go on another excellent adventure. Yes, way! Okay, let's start off with managing a treasury. So this could be a corporate treasury or it could be a DAO treasury, right? DAO governance is tough. Okay, so let's imagine that you just did an ICO for tens of millions of dollars and you are seeing green. You have enough money to build your protocol, go to market, no, you're never going to get users. But you have a lot of runway. So one of the worst things that happens when you have a lot of money is people start coming out of the woodwork asking you for money. You have centralized exchanges who are willing to list your token for an arm and a leg. You have market makers who are willing to provide liquidity and structure the markets. And you have third-party developers who are happy to take some of the development work off your shoulders. And you go very quickly from seeing green to seeing red. Now, this is a problem which many of us have faced. So how do we solve it? Well, one way is with sealed bid RFPs, or requests for proposals. And this is not something that crypto invented. This has been used for decades by large corporations and government departments. And in fact, 7 years ago, the OECD published a working paper about public procurement, and they compared sealed bid RFPs to open bid RFPs, and they found that sealed bid RFPs are actually more fair and more competitive and yield savings to the company or government that organizes them. 17% on average, in fact. And this can add up to tens of thousands, hundreds of thousands, or millions of dollars of savings for a company or a DAO. So how do we do this? Well, launching soon, we're going to have the Shutter sealed bid RFP platform where your DAO can create a competitive RFP. All you need to do is hop on our platform, add the title, a description, but most importantly, you need to add the submission deadline and then the reveal deadline. After you publish it on our platform, you can publish it on Twitter, on forums, wherever you like. And the vendors will go to work. The vendors will submit their bids, but they're not going to submit them by sending you an email or by posting on your forum. They're going to go onto this platform and they're going to put in their name, the service that they're providing, and how much it's going to cost. And then what they're going to do is encrypt it. At the end of the bidding process, when the submission deadline has passed, then all of the vendors' bids are decrypted and revealed at the same time. And this has two really important benefits. One is that vendors cannot see one another's bids, so they can't play games or front run each other or use information asymmetry to their advantage. And also, the DAO, the organization, doesn't see the vendor's bids before everyone else, so there's no way for them to play favorites and to leak vendor information to their preferred vendor. Okay, let's talk about winning friends and influencing people. I know all of you are on crypto Twitter, and you should move to Farcaster. But one of our favorite games that we like to play on social media is basically showing that we have alpha, that we knew something before everyone else. And a really cool way of doing this is with dropping hashes. So let's say I'm a security researcher and I find a vulnerability at Google. What I can do is I can write up a paper with all of my findings and I can generate a hash, and then I can publish my hash on Twitter or Farcaster, a place where it's publicly visible and it cannot be changed, like this. And then what I do is I release my findings privately to Google and let them have the opportunity to fix the vulnerability and publish their solution. But now I've got a problem because nobody knows that I knew that information before Google. So what I can do is I can then publish the paper and tell people how to compute the hash. And if the hashes match, then everyone knows that I had that information before Google published it. In other words, I had the alpha. Another thing we like to do on crypto Twitter is we like to pretend that we're clairvoyant, that we can see into the future. And so you get really annoying posts like this one, or predictions like this one from Arthur Hayes, who said that Bitcoin would reach $1 million by 2028. And this is super frustrating because talk is cheap and we want people not just to have predictions, but to plant the flag and make their predictions serious. So we created Shutter Predict, which does encrypted predictions. And here you can have your prediction. My prediction is that ETH will hit 20,000 by the end of 2025. And it should be revealed on January 1st, 2026, right? So what I do is I state my prediction and the reveal time, then I encrypt it to generate ciphertext. I then commit to it, and I post it on Twitter. Now, one of the really cool things about Shutter Predict is that on January 1st, 2026 at noon, Shutter Predict will actually quote tweet this tweet with the decrypted prediction that I have done now. So basically, this is a super quick and easy way for me to make a prediction which I cannot change, which I cannot block in the future, which will be revealed automatically and then published on Twitter. So if you have alpha, use Shutter Predict. Last, survive. Crypto is all about surviving. And I hate to tell you, but every single person in this room is being stalked by an international organization of criminals. They have 1 million agents operating in 66 countries worldwide, and they have stolen more than $1.5 billion in the past 4 years. Am I talking about Lazarus and North Korea? No. I'm talking about Ethereum. I'm talking about our beloved world computer, our beloved infinite garden. And I see some of you, you're bristling, you've got your back up, you're ready to come up on stage and fight me. Well, I have bad news for you. All of us are participants in this system. All of us co-create Ethereum together. So it's not just our convoluted transaction supply chain. It's not just malicious MEV bots like Jared at subway.eth. It's actually you and me, everyone who holds ETH, everyone who runs a node, everyone who develops on Ethereum. If you are not fighting tooth and nail to eliminate malicious MEV, you are condoning and participating in organized theft at a massive scale. And I encourage you at every opportunity, call out malicious MEV and the people who enable it. And let's rid Ethereum of malicious MEV once and for all. And there are tools where you can learn about malicious MEV. Shout out to EigenFi that publishes detailed explanations of common exploits, of MEV Scanner that publishes weekly updates on the amount of MEV stolen each week. But as I mentioned, $1.5 billion have been stolen from normal crypto users, people like you and me, in the past 4 years by malicious MEV bots. So if we want to say that Ethereum is fair and credibly neutral, we need to do a better job of upholding our own values, of crypto's core values, of Ethereum's core values. And one way we can do that is with encrypted transactions in the public mempool. And if you're familiar with Ethereum's transaction supply chain, it's actually a pretty simple process. The user submits a transaction, and using an encrypting RPC and the Shutter Keeper network, we encrypt the transaction and add it to the public mempool. Now, MEV bots can see that there is a transaction, but they can't see the contents of the transaction. And as a result, there's no way for MEV bots to front run or sandwich attack that transaction simply because they don't know the contents. They're blind. Then the builder confirms the transaction in the order in the block, at which point the validator and the keepers collaborate to decrypt the contents of the transaction, and it gets added to the chain as normal. This is a very simple way to prevent malicious MEV while still allowing benign MEV and also not introducing additional centralization. So, this has been a brief introduction to commit and reveal threshold encryption and everyday use cases for it. If you're interested in learning more, you can head over to shutter.network. And if you're a developer who would like to use commit and reveal threshold encryption in any off-chain application or any on-chain dApp, you can actually utilize the new Shutter API and get started in just a couple of hours. Thank you very much.
Unfortunately, we don't have time for questions, but will you be available outside? Amazing. Thank you so much.
Thank you.